Can you hear me?
Yes, Prof.
Okay, thank you. So
I sent you invitation. No, not invitation. That our paper will come up today now. That our paper, you are going to join, right?
sorry.
Help me to call Amadi to also join.
So I think meanwhile we can already start our session. So the first paper which will be presented is The Pathology of Failures in IoT Systems by Mario Melo and Gibeon Aquino. Is the presenter here?
Yes, I'm here.
Okay, so Mario, you can start sharing your screen. Thank you.
Thank you. I'm going to project my screen. One
Sure.
minute.
You are muted. We cannot hear you.
I'm sorry.
No problem.
Hello, everyone. I'm going to talk about today about the pathology of failures in IoT systems. Thank you for joining this presentation. And a little agenda of we're going to talk about today. Brief introduction, the pathology of failures. We're going to talk about the source of faults in IoT systems, a proposed taxonomy of faults, the failure propagation model. At last, we're going to conclude our study. IoT has attracted attention by projecting the vision of a global network of physical objects, enabling connectivity anytime, any place, for anything and anyone. IoT has made everyday life more pervasive, personal, and intimate through technology. So, fault management plays an essential role in maintaining these IoT systems in a regular operation, decreasing or even preventing faults, errors, and failures, which leads to increase the dependability property, which is included reliability and availability. IoT systems often have particular requirements regarding fault management schemes, include specific fault characteristics due to their heterogeneity and complexity. Although significant attention has been given to dependability aspects in IoT systems, no comprehensive, consistent, and generally adopted fault characterization explain fault causes and effect in these systems. So, the objective of this study is to propose pathology of failures in these systems, providing a standard definition characterization to assist researchers and practitioners in developing appropriate fault management solutions. So, we focus on identify the cause of faults, what are faults and errors manifestation types, and how a failure propagation occurs in this system. Thus, this research aims to establish the characterization, origin, and behavior of faults, errors, and failures that compose the pathology of failures in IoT systems. The pathology is divided in 3 steps. The first one is the source identification, the fault source identification, which classifies where are the source of threats. The second one is the fault error taxonomy, which classifies what are the type of faults that could occur. At last, we have the failure propagation model. Due to interaction independence between different devices in function or structure, propagation and cascading faults require understanding and investigation. The source of faults. The sources of faults are divided in levels of an IoT system: perception, communication, service, and application. The first one is the perception level, which are placed the sensors, which are physical components such as sensors, actuators, mobile devices, mechanical components that can produce faults. Some examples of social faults are physical stress on components, inadequate enclosure, harsh environment deployment, low energy could cause physical device to malfunction, disruption, direct intervention, or destruction. Process units, which encompass sensor node process related components such as memory, battery, microprocessor. Some examples of faults are memory bit flips, limited memory fault or memory errors, high battery temperature, or low battery voltage. The network sublevel in a perception level is the formal communication utilized to connect devices that can be wireless or wired, which each one suffer different type of faults. Wireless communications are normally prone to interference, such as ambient noise, channel noise, multipath fading, radio frequency interference. Wired communication is vulnerable to a broken connector, such as material decay, environmental effects, such as dirting or even breakage. At last, we have embedded software, which has the algorithms running inside the nodes presented as the perception level. Examples of faults are data process faults, incorrect design specification, architectural faults, software design faults, or incorrect algorithms. In the communication level, we have 2 sub-levels, the link level and the connectivity sub-level. The link level is where the establishment of the communication is occur. Some examples of faults that could occur at this level are unwired connections are stable but are exposed to the disruption, and the wireless one are highly volatile, leading to not always yield to the same message delivery rate. Also, we could have link stability that can lead to faults in the routing paths, interference, collision, and data loss. At the sub-level of connectivity, we have problems such as routing path faults, interference faults, connectivity faults, and protocol violations. At service level, this level is mainly qualified for storing and processing mass data in IoT systems. The faults are normally linked to hardware and software threats. The hardware faults are normally linked to hard disks that degrades its function due to temperature fluctuations, network connectivity issues, service unavailability. Other faults linked to software are contextual situation faults, such as wrong data collection, erroneous inference, and loss of events. System control restrictions, such as input errors, deadline miss, or engine effects. And data faults, data corruption, mis-source data, wrong computation, among others. At the last level is the application level, which are normally the type of faults are linked to software bugs, operating system errors, unhandled exceptions, and incorrect usage. We also propose at this research a taxonomy of faults. This taxonomy organizes the faults according with its types. The first one is duration. The duration type of fault could be transient, permanent, intermittent. The transient one are faults that are temporary. Permanent always produce errors, and intermittent are developed in a longer period compared with transient faults. The second one is location. The fault could happen internally in the system or can come from the outside. The third one is semantics. Semantic faults could be a crash, which occurs when an entity loses its internal state, it cannot respond to requests. Omission is determined by a service eventually not responding to requests. Timing occurs when a service responds to a request out of time. Value produced when a service sends a timely response to a request with an inaccurate delivery value or an incorrect state transition. Arbitrary include all previous types that cannot be classified in the described categories. The next one is behavior. Behavior faults could be classified as soft and hard. Soft, the system operates with altered behavior. Hard causes general inactivity in the system. Dimension faults could be softer or harder. Softer only placed at software level and harder at hardware level. And the last classification is the level, which was already explained in the previous section. We also propose a failure propagation model. The failure propagation model established the path that a failure can propagate in the system. The failure could propagate intra-level, between levels, inter-level, inter-systems, and inter-environment. So, faults in IoT system, if they are not treated properly and become system failures, may interfere with users' everyday life or even lead to danger in their lives. To design and conceive efficient fault management strategies, we defined the pathology of failures for IoT systems. This pathology was divided in 3 steps: identify the source of faults, the taxonomy of fault and error, and the failure propagation model. As future research, we intend to propose a novel fault management framework for IoT systems, which can manage fault failures, consider the level of interdependence and propagation of these systems. Thank you.
Thank you, Mario, for the interesting work. Surely it's really important to classify faults in order to know how to react to them fast and effectively. So this is an interesting work for sure. Is there any question? If there is no question, we can...
I have a question, please.
Yes, please. Go on.
Okay, my name is Kennedy. Just a very simple question, because this presentation, appears very interesting, and I'm working in that area as well. So I just have a very simple question, and I would like to have a very little clarification. So you're talking about a fault classification, especially with IoT sensor. If you have an IoT sensor node that can maliciously, fake identities of traffic. For example, you have an IoT node deployed in a place, and then this IoT node is able to fake identities. Please, I would like to find out this type of attack. When you have this kind of sensor node placement and there's a malicious node faking identities, this kind of attack, how will you classify it? Within the taxonomy that was presented, such attack, where will you classify it? Attacks on sensor nodes, like Siebel attack,
could be classified as fault, data fault, crash fault, or even a software or hardware fault.
Okay. So in this research, do you have any mitigation framework for mitigating against such kinds of attack, especially when you have sensitive transactions going on within that IoT deployment?
Can you repeat, please?
I'm asking, within the taxonomy that you've just shared, is there any mitigation you can recommend for that kind of scenario? Is there any mitigation framework or you can recommend, especially when you have IoTs dealing with sensitive data and transactions?
In this work, we do not propose any mitigation form, but we are thinking of expanding this research to do so.
Okay. Thank you.
Thank you for your question.
Okay. Is there any other question? If not, we can move to the next speaker, who is Nikolai Voigt or Semyon Bochkov.
Yes, Semyon is here. Yes.
Okay, Semyon is connected. And the paper title is Method to Convert UML State Chart Diagram to the Virtual Object Mockup. So,
Okay, so
please, Semyon,
yes,
you can start presenting.
Show the screen. Так. Just a minute, please. So, do you see the presentation?
Yes.
Yes. Okay,
Perfect.
let's start.
Thank you.
So, 1 minute. So, good afternoon, colleagues. My name is Semyon Bachkov. I'm a PhD student of Ulyanovsk State Technical University. I'm very glad to take part in ICCSA conference. Let me introduce the report on theme method to convert UML state chart diagram to the virtual object mockup. Nowadays, most industrial enterprises successfully use virtual reality technology to solve a variety of different tasks. Personal training and retraining on the workplace, modeling of assembled products, complex physical process taking place inside products, and on the manufacturing line. VR is used throughout the entire project life cycle, from the early design stages, error identification, ergonomics checking, to the production process organization, development of maintenance, repair, modernization processes, demonstrating the future product to customers even before production with the VR allows the client to see a life-size item and touch it, to interact with it, and also to test it before it comes to production. It becomes evident that one of the keys to a successful VR software product is the design process and design solution in form of documentation. The process should be as short as possible, and project solutions in turn must contain a detailed description of the developed object. In other words, project solutions should be clear for every member of the design team and adaptive under new requirements. Complex technical systems, including those used in VR technology, are designed using diagrammatic models, which are the artifacts of the various visual graphic languages such as CSML, BPMN, UPC, or UML, of course. So they significantly increase the efficiency and quality of design procedures by unifying the language of interaction between process participants, including developers, clients, representatives, through thorough documentation of design and architectural solutions, formal methods of checking diagrams for correctness. Automata models, or automata, or simply state machines, are the most common means of representing systems at a high level of abstraction, which gives developers the most complete understanding of the software system principles. There is a wide range of reverse engineering techniques, getting state machine from source code to obtain concise and up-to-date documentation on how the system works. And nowadays, UML 2.0 is de facto the standard in the object-oriented modeling and design. This is the most popular language for modeling reactive systems. It's intended for designing, documenting, modeling the behavior of system artifacts, and it's widely used in technology and industry. UML state chart diagrams are of particular interest, so they model the system behavior depending on external actions, internal actions, which are in fact analogous to state machine models. Thus, combining UML state chart diagrams and state machines to automatically synthesize virtual objects or virtual mockups allows expecting reducing time and resource costs in tasks. The problem is that projects nowadays became more and more complex. So the larger the diagram and the more types of them are engaged to model such a complex hardware and software systems. So the more complex system becomes, and the visual system prototype is hard to understand and maintain. A large number of virtual mockups also exist, but there is no unified approach transforming descriptive models, especially in above-mentioned visual languages, to the ones which can be applied to virtual reality. So when we worked on an article, so we were researching a lot of articles, and I should say that there is a few works which concern some formal scientific problems of generating virtual objects with some state machines or other types of diagrams. But also there exists some products. We also considered it, we tested it, several software tools, but they didn't meet our requirements. So we just founded a task on how to convert virtual mockup, UML state machines to virtual mockups. So just UML state machine is, as was stated before, one of the most convenient form of image to model object behavior. So on the slide, you can see an extended finite state machine. So the UML CHR diagrams can be expressed via such machine. So it consists of sets of states which are divided into simple or atomic states and complex states, which in turn consist of regions, also set of states with their transitions, input signals, and so on. Also, EFSMs contains an initial state, input signal state, condition state, initial state function, so which shows which state is an initial for every region. And also, EFSM contains the transition table. So each transition includes source state, destination state, input signal, and conditions to transit. So if condition is true, then transition can be performed. Otherwise, no. And as you can see, transition can have an empty condition which is equal to true. So there is no condition to transit, and everything okay. Virtual environment consists of objects the user interact with. We assume such objects as virtual objects or virtual mockups. So because this is not real object, this is just a prototype of object in virtual reality that user can touch, interact. But the mockup models the behavior which is well, almost real on some levels to real objects. And we formalized also virtual mockup with the model you can see on the slide. It contains of controller sets the user interact with, and the user can change the state of virtual mockup. Events, this is just like input signals. Also functions, with which user can change the state of virtual mockup. Function mapping. So I will say after what is it on the next slide. Also, virtual mockup consists of states and initial state. So we introduced the events mapping function, which maps each EFSM input signal from input signal state X to the couple of event type from events and controller. So it has one-to-one relations, and thus has the description you can see on the slide. So each input signal matches in real life and an event, and controller in events occurred too. Also, we introduced the states map, which maps a state from EFSM to state on virtual mockup, and a couple of functions which returns EFSM state and mockup state respectively. Also, the formal description you can see on the slide. So this is conversion methods. Formal description of conversion method is given in the article. So the sizes of presentation do not allow to put it, and just shortly in common, I'll tell what it is. So firstly, we copy states from state machine to virtual mockup model. Initially, we copy simple states and complex states. Then on step 2, we copy transitions. Also, transitions are different. Firstly, we copy transitions between atomic or simple states. Then we copy transitions which are inside one state. So transitions between two states which are inside one region of complex state. Then we copy transitions from a simple state to complex one. And at last, we copy transitions from complex states, which from complex state to simple one, from simple one. So here are two examples. So we tested the methods on two devices. On the slide, you can see an oscilloscope S1-116. So on the slide, you can see virtual mockup formal description, textual descriptions, so controllers, event types, states, and initial states. Also, the device is complex. It has large amount of controllers, and you can see that this is a fragment. So also, I was afraid that full list will not fit into the slides. So, and I chose the best controllers, the most interesting. Also, even here are event types. And this is the finished state machine, also a fragment from a big, huge state machine. So, and on the slide, you can see this input signals, guard conditions, states of state machine, and initial state. On the table, this is a textual description of events mapping function. So this formal description is converted into this device. The second example is timer counter analyzer CNT90. Also, here is a list of most controllers, also event types, which are included in mockup model. Also states, which will be on the next slide, and initial state. So this is also fragments of finished state machine of CNT19. Also here is events mapping function, and just sets of input signals, guard conditions, and states. Well, we have developed method converting UML state chart model to the virtual mockup, and it differs in the use of events mapping function forming human-computer interaction scheme. The method uses state chart model developed in accordance with UML 2.0. Generated virtual mockup reflects its behavior features depending on external triggers. The method is hardware-free and can be applied in generation of the program code modeling object behavior in virtual reality. And the next research topics are the following. So we are researching to extend the method for the multi-object dynamic systems, development and analysis of virtual environment using other UML diagram models such as use case, sequence, activity diagram, etc. Thank you very much for the attention. And if you have any questions, so I will answer.
Okay, thank you very much for that interesting presentation. Are there any questions from the floor?
Okay, question again.
Are there any questions from the floor?
Yeah, question. I have a question for.
Yes, please go ahead. Yes, thank you.
Okay. So beautiful presentation. Thank you for that presentation. I just want to find out. Besides virtual reality, where are the use cases where we can apply?
Use cases of our project. Yes, this you mean?
Yeah, exactly. Besides virtual reality.
Sorry, noises. Well, so the most evident use case is industry. So if in some enterprise some products are produced, so and we need to test a new one, well, and for example modify it or principally new. So it can be expensive to to build a prototype and to test it, and even it can be dangerous. So sorry, I hear myself. Okay, thanks. When prototyping the object, we can in virtual reality test it, touch it, so just check some ergonomics of the object before to put it on the production line.
Okay, thank you very much for that response. Are there any further questions? Okay, in the absence of further questions, thank you very much for your presentation.
Thank you very much.
Are there any other presenters in the room? Please let us know.
Yes, we're here.
Okay. Your name is?
My name is Kennedy C. Okafor.
Okay, Kennedy, you're presenting using edge to cloud analytics, IoT, dump site monitor to proactive waste management. Yes?
Absolutely, correct.
Thank you very much. Welcome, and you may share your screen and commence.
Okay, thank you very much. Let me share my screen. If you can see my screen, just let me know.
Yes, we can see it. Thank you.
Oh, absolutely. So great. So good afternoon from this part of the world, Nigeria, to everyone on the platform. I'm happy to be in ICCSA 2021. So we are presenting a paper with caption using edge to cloud analytics IoT dump site monitor for proactive waste management. Our PI, principal investigator, on behalf of PI and my research team, I'm going to be making this presentation on our behalf. So this is actually a sponsored research grant we got here in Nigeria to build a waste management and IoT monitoring dump site system. So it's an entire value chain, but we're going to be focusing on the IoT aspect. So this is the outline of my presentation. I will talk about just the background, the waste concerns, the research gaps, and edge to cloud analytics solution methodology, the state diagrams, architecture, and sensor characterizations, result analysis, and then conclusion, future works. Okay, so let's give a context. Let's talk about the African market outlook. But before that, I say waste management deals with the entire value chain, processes, and actions needed to manage waste from its inception to its final disposal. In most cases, it involves collection, transport, and treatment of this waste together with monitoring and regulation, and then leveraging existing laws with technologies and economic mechanisms. Within the African context, this is growing. Waste management market is growing, and it's growing at a compounded annual growth rate, and is expected to grow with an average waste collection rate of only about 55%. We have inadequacies in municipal solid waste collection services in many African countries, Nigeria inclusive. About 90% of the waste generated in Africa is disposed to the land, and typically uncontrolled in most cases, and then some other time controlled dump sites. It's a major concern. About 4% of this generated waste in Africa is recycled, and often by informal sectors. That's quite small, 4%. And Africa has become a dumping site for most waste, particularly hazardous, waste. So our concerns here in most communities, most villages, and most environments within the Nigerian context now is that we have absence of robust waste management system. Nigerian population grows even at 2.6 annually without any robust waste management evacuation systems in place. We have environmental concerns, especially the potential risk emanating from unsustainable waste disposal systems. Most towns and cities are have dump sites that are close to residential areas, and that's a big problem. Climate change and urbanization waste concern. Sometimes we have blockages of access roads and the drainage systems, most often empties into rivers that most communities use for domestic purposes, and that's a big concern. But however, recently the informal sector have started to do waste collection, but their impact is quite not significant enough, so it's a major problem. So from the literature and the things we've seen from our survey, we observe that despite the intervention by various organizations, researchers, little success have been recorded, especially in the domain of waste management analytics needed for environmental and public health decision making. That's very critical. There are non-existent technological solutions for dump site monitoring to mitigate potential hazards, especially some of the biological hazards resulting from the biodegradable substances and the gaseous waste in these dump sites. They need to be tracked and monitored. Non-existent solution again for power-constrained IoT deployment in remote environment without power grid. So when we deploy IoT devices, because they have power constraints, there's need to sustain the power within this deployment environment so as to be able to help us monitor what is going on in these dump sites. So non-deployment of edge analytics in process automation, that's a major concern. And several other concerns, within this space. But primarily our solution set borders on the waste management and hazard alert system, which is a research project involving the use of ICT re-engineering for business model and be innovative business model to create synergy among stakeholders within the waste management supply chain, waste generators, evacuators, and recycling companies. So we want to build an ecosystem of waste management, that will involve all the relevant stakeholders, and then talking to each other using data aggregated from these dump sites. That's where the IoT comes in. So our objective function here is to derive what we call a complexity diffusion function. This involves the introduction of state-of-the-art proactive approach to avert hazard from dump sites using IoT smart sensors and cloud-based predictive visualizations. So here we aggregate sensors that can capture various gases and substances, and then these captures can be pushed to the cloud for analytics and decision making. Okay, so next slide now. So what are the features of our edge to cloud solution space? One, hazard control. Our system have the capacity to capture these sensed elements from multiple dump sites, and then be able to profile them within the cloud space for analytics. IoT sensors and cloud predictive visualizations were leveraged in trying to achieve our complexity diffusion control. So edge to cloud analytics involves stream computing analytics is another future, because this IoTs captures these gaseous substances and then pushes it through the fog and then into the cloud. And then we have to introduce a power conservative model, the simultaneous wireless information power transfer protocol scheme, responsible for conserving energy within this IoT deployment. These are very useful, especially with respect to power inadequacies in these dump sites. Now we have a prototype IoT edge nodes with this SWIPT for real-time monitoring of these dump sites and mitigation against hazards. Other contributing features of our system involve lightweight API, application programming interface service for microservices communication from the dump site to the cloud via the fog. And then API containerization for light deployment using Docker Swarm and the Kubernetes. Then QoS metrics using service throughput and latency profile for IoT dump sites, and then test performances. Some of the last two are still under investigation as part of our future work, especially API and QoS optimization. So in our methodology, trying to look at the complex diffusion function I mentioned earlier on, our team visited various dump sites. We met with informal recyclers, waste contributors in two states within the Nigerian environment. The Imo and Anambra State dump site, and then we were able to develop smart sensor nodes for monitoring dump sites, And then the block model for our system actually is shown by the left of the slide, where we'll have users interacting with, a website platform that's on that interface, and then talking to the NOC, the Network Operating Center, and then interacting with government agencies. And then you can see the IoT sensors interacting directly with the, NOC, the Network Operating Center, where the nodes gaseous substances like flame, carbon monoxide, nitrogen, and the rest are captured and then transmitted to the NOC for analytics. Okay, so now this and that aspect of the work where we talk about the energy management system, because these nodes, when deployed on dump sites, must be managed so as to conserve the energy and then allow them to capture as many gaseous substances in the dump site as possible. So the energy management system, the framework implementation is actually shown on this block diagram from the power supply, which is enabled by solar panels, about 12-volt solar panels at that edge, and then connected to the sensor nodes, and then through the controller, it goes through the fog IoT gateway, and then the cloud for analytics. So the state transition diagram is shown here. From the node deployment, we'll have the calibrations of these nodes, and then from the calibration, I'll move to the sensing edge, because this involves action and events, and then each event triggers an action within the transition states. So from the node reading, gaseous substances that are detected are transmitted to the fog layer through data transmission, and then from the fog layer, it moves to the cloud for analytics and decision making, and then the process recycles. So this is state transition representation of our edge to cloud deployment. So our architecture involves the use of edge controllers, MK1000 for edge to fog cluster head gateway processing, the cloud APIs for full duplex communication, and then the cloud IO data streams located in the pod clusters in the servers. So the diagram here represents the activities from the dump sites down to the edge nodes, down to the cluster heads for the fog gateway, and then to the cloud servers that are running on containerization and virtualization, supporting the analytics that we talked about. So we have three major algorithms for optimization: the IoT node characterization setup, the sensor node reading, calibration, and data transmission to the cloud server. This is the first algorithm for the nodes IoT characterization. The second algorithm is for the sensor reading and calibration. And then the third algorithm is for data processing to the remote cloud. One interesting thing about this algorithm is that we have to integrate a seamless API controller, API service that pushes this data from the edge to the cloud. That API service is customized, and then we use our ThinkSpeak cloud platform to test it out. Now we look at the node characterization, where we'll talk about the complexity division function. From the data source, the edge, we have these different sensors aggregated in this summation function. And at the concatenation, the different elements are captured as measurable quantities. And we used this model to represent the variations in voltages, and of course, integrating them with our analog to digital converters to our MK1000 controller, which is responsible for pulling out these gaseous substances from these nodes into the fog gateway and then into the cloud for analytics. So the same function, we characterize them, converting the analog variations into the binary and then to the string equivalent, which is responsible for the fog diffusion into the cloud. So these functions are represented: the flame, the smoke, the gas, and then the battery level captures from the edge. And so the summation gives us the complexity diffusion function, which is represented in equation 11. This equation is very significant for our fog to cloud transmission. And so we were able to do that, and then brought in the components involving MK1000 controller, the lithium battery, the gas sensors, the MQ7 and MQ2, flame detectors, transceiver, with solar panel that is responsible for powering the nodes at the edge, and then the API that runs on the ThinkSpeak cloud. And then we're able to build the simulation context, and then we're able to observe the physical characterizations and as well as the API interactions And then at the end of the day, we're able to build a proof of concept that allows interaction of the API scripts from the MK1000 to the ThinkSpeak Cloud. These are the prototypes for the system we built, involving the circuitry, the battery model, the solar edge, and then these are the end products that we built for the system. So in analysis, we're able to interface our API with our ThinkSpeak Cloud, and then with the API service, we were able to establish seamless connections from the fog gateway into the cloud. As long as the events are triggered at the edge, that is the dump site, these events are pushed to the fog gateways, and the gateways uses the API to transact with the cloud environment, and then we're able to do the visualization of real-time processes happening in the edge of the dump site. So these are the activities, test case dump site activities. We were able to monitor the battery level. We were able to monitor the frame level when we subjected them to physical characterization of activities happening real time in the dump site. And so this characterization enabled us to pick this data output from our ThinkSpeak server to show these responses and their behavior. The gas levels, the smoke level, the flame level, and the battery level were all captured. So in this case, we can stay in the cloud environment and then determine the thresholds for critical condition and for decision making. So in our conclusion, we have been able to establish a novel way of doing edge-to-cloud analytics within the dump site environment. And that's actually the core, especially for the IoT waste management and hazard alert system developed for management of waste dump sites in our environment. We've shown that this node can capture various gases, emissions, smoke and fire, possibilities in this dump site. The complexity function we mentioned remains scalable and is efficient for data streaming. Now uploading from these IoT sensors into the cloud from the MK1000 edge controller. So we've been able to do the proof of concept. We've tested our deployment visualization pattern in an open source ThinkSpeak native cloud environment, which is very good. And then we've been able to see results. Further integrations are still going on to allow for calibrations and the real-time decision making as the dump sites are in operation. So our key contribution have been to use the edge to cloud analytics for dump site monitoring and prompt evacuation, introduction of SMIP, synchronous wireless protocol to conserve energy for optimized value insights, and then deployment of architectural model that lowers compute storage. And then summarily, IoT analytics is actually recommended for sustainable model for waste management in Nigerian environments, especially for hazardous substances that can actually trigger events and then create problems as far as climate change and environmental trouble challenge constraints are concerned. So I want to say here that this research have been able to produce a novel approach to dump site management, and then this will be useful to recyclers, to waste management vendors, anywhere within the developing countries to solve the problem of waste. Thank you very much. And I'm very grateful to TETFund. We are grateful to TETFund and the University Federal University of Technology for the support in this research. Thank you very much.
Okay, thank you very much for that interesting presentation. Can we have questions from the floor?
Yes, Kennedy, well done.
Thank you, Prof. Thank you very much, Prof.
Okay, so what is the major contribution you achieved in your work?
Sorry, can you repeat again? Sorry.
What is the major contribution you did it in this work?
Okay, our research, we have been able to show a novel way of tracking gaseous substances resulting from biodegradable waste in dump sites, and then tracking them so that we can actually use their thresholds to take certain policy decisions. We can decide to build methane gas plants in dump site near certain locations so that we can actually generate energy from edge dump sites. That's one of the things we discovered. We've been able to contribute in trying to determine a very seamless wireless communication protocol that can conserve energy of IoT nodes in dump sites. Hello, Prof.
Hello, I think we
Hello, Prof.
having a connection problem.
Okay.
Okay, we're back.
Okay, Prof. Okay, Prof. Can you hear me?
Ask from the audience. Have you any question from anybody?
Okay, my PI is
Okay,
here.
Gloria, you are welcome.
Thank you very much. I
Good
thought
afternoon,
I
ma'am.
was joining early. You have started presenting.
Yes.
Good afternoon, ma. You are welcome.
Thank you so much.
I never knew that you are coming. Otherwise, I will ask you to chair this session. You know, the Professor Gloria is a past chairman of the IEEE Africa.
Thank you very much. Thank you for recognizing me. I was thinking, okay, so that's fine. That's fine.
You are welcome. Our next session is starting in 15 minutes. This is the tea time. So I invite you a virtual tea for everybody.
Okay. Prof, you might share
presenter.
it through the. Okay.
Please remove your presentation, Kennedy.
Okay, Prof.
Prof, there is one more presentation predicting student academic performance.
Is remaining? Is it not the last one?
The last one, yes.
Okay, so let him present if he is present. Yes, please.
Yeah. Is anyone to present the paper predicting student academic performance using machine learning? No, I don't think so. Anyone's here for that one.
He was here. Yes, he should be there because it is the Fudoshayani is from the US.
Oh, Yoani. No, it doesn't seem as though anyone's here.
So, Jay, how many papers are presented in this?
There were, I'll tell you now, there were 3. There were 3.
3.
Yes, 3.
Okay. Have you started the session in time?
Yes, the session started in time.
Because I got a message from somebody that session is being given. Okay. It's okay. It's okay. Otherwise, let us for a 10 minutes. It is the 10-minute break, right?
Sure. Yes. We'll start at 16:30. Yes.
For the 10 minutes. So we will return back. I'm around now.
All right. Okay. Thank you.
Okay. So please be present. Okay. I'm also there.
Yeah. Sure. Okay. Thanks.
Thank you. So next paper, Jay, is from your university, right?
Yes, and you no.
Is he present? Is he or she, Samuel, is going to present, right?
Oh
Professor
yes,
Richard
yes,
is there.
yes. Samuel or Israel? Is
Samuel
it?
from Israel.
One of them is presenting. Let's see who's here.
Okay. Okay, Samuel or Israel. Okay. I I thought that you are saying Samuel is from Israel.
No, it's Samuel or Israel. Okay. Good
Yes.
afternoon, ladies and gents. Just a note on housekeeping. There are 2 or 3 people. If you can please go to settings and type in your name so we can see who you are. If there are any presenters in the room, please let us know so we can commence.
Can you please change your name? Yes, it's better to not as a. It will
Fellow
be easy for us to identify the.
I think you're self-prof as well. You need to change your name so we can see who else is left.
So how many presenters are present in this room?
There are 4. 1, 2, 3, 4. I don't see anyone at the moment. Are any one of the presenters here?
Okay, so let us start. I think if moderator is there. I think moderator is not written back right now, right?
Sorry, who's that?
Hello. Should we start?
Yes, we can start. I don't see the presenters here, though.
None of them. You can call them.
I can make a call to Prof. Let me phone him quickly and ask him where's the presenters. Give me a minute.
Yes, please.
For Richard. I'll try and call Richard.
Is the second presenter Chamundishri or Kavya Jonathan, Lakshmana Murugan, Kartika Menon is around? Is the second presenter around?
Yes, sir. We're just waiting for our team members to join.
Yes. Who are you?
I'm Lakshna, sir. The second.
Okay, Lakshna Murugan, right?
Yes, sir.
So who is presenting this work?
Just a second, sir. My other teammates are yet to join. I will just ask them to join first.
Hello, Prof.
Yes, Jay. Is there around?
No, I don't see anyone around. I'm still trying to get hold of Prof. Milam, but we can continue with the second presentation in the meantime. Israel or Samuel, are you around? Sam. No, we can carry on with the second presentation, Prof.
Can I start?
No, because second and fourth, I know it is from Chamuteshri,
Sorry.
and she requested me to present by their
Yeah,
student.
okay.
But I am not sure that all the students are around. What's happened, Lakshana?
Yes, sir. They're having
This is Samuel.
network problems. They're not able to hear anything.
Lakshana?
Yes, sir. Can you hear me?
Yes, we can hear you clearly.
No, the thing is,
I can hear
my
you. Who is going to
my,
present this paper?
my other teammates are not able to like hear or like access this. So just 2 minutes, sir. We'll figure this out in a bit.
All right. Samuel, are you around? Samuel? I thought I heard a Samuel.
Hello, Prof. Please, can I start?
Yeah, who's speaking there?
Hello, yes.
Who is this?
Who is there?
What's your paper title?
Who want to start? Please, can you?
Oh, you're not audible. Sorry, but I can't hear anything.
Okay, what is your paper title?
Hello.
Okay, so we have
Hello. Yes, who want to present?
Alessandro. Alessandro, can you hear us?
Hi, yes, Kenny, I hear you, but I'm not the presenter in this session. I'm just, let's say, watching as a normal user.
It's okay.
Thank you for joining us.
Who was speaking? It seems to be Sam.
Sam,
or
yes,
something
yes.
like that.
Yes, that's right, that's right. I'm trying to find out what his paper is.
Number one, I suppose, as there is in paper number one, there is a Samuel Ofori. Sorry
yes,
for my...
Sam is here, yes. And I'm asking if I could present.
Samuel, yes, please, you can present. Yes, you can start now. Thank you very much, Samuel, for joining us.
Samuel there?
Please share your screen. Samuel.
Okay.
Samuel, we cannot see your screen. Samuel, if you can hear me, you need to share your screen.
Yes, please share your screen. What's the problem? Samuel is there.
Yes, please go ahead, Samuel.
Is Samuel there, right?
Yes, Samuel is here, but he's having a problem, I think, sharing his screen.
Yes, Sam is there. So also I can see the Samya Ramesh from the last presenter. Are Samya ready?
Sir. Yes, sir, we are ready, sir.
And what about the second one? This is the Lakshana.
Yes, sir. We're also ready.
So go for the second presentation.
Yeah, I think so.
Samuel will
I
present
think so.
after then.
So who's presenting in the second presentation?
Lakshana, please share your screen.
Oh,
Yes, sir. Yes, sir. I'll be sharing. So is it visible?
Yes, we can see. Thank you. Please commence. Thank you.
Okay. So I'll begin now, sir. So, respected members of the panel, we're here for the presentation of our paper titled COVID-19 Diagnosis from Chest X-ray Images Using Convolutional Neural Networks and Effects of Data Poisoning. As we all know, the COVID-19 pandemic is one of the greatest health crises faced by the world till date. But one of the major problems that stands in the way of the diagnosis of COVID is the fact that the symptoms of COVID and a viral pneumonia are almost the same. So chest X-ray imaging is the first diagnostic technique that has a significant role in the diagnosis of COVID-19. But sometimes doctors and health professionals find it difficult to look at the features in the chest X-ray images and distinguish between a normal viral pneumonia chest X-ray and a COVID X-ray. That is the purpose of our research. The purpose of our research is to segregate the chest X-ray, segregate the chest X-rays in the data set using pre-trained convolutional neural network, which is ResNet-18, into three classes, namely normal, COVID, and viral. The results are extremely encouraging and show that using deep learning techniques on chest X-ray images can be used to accelerate the diagnosis of COVID-19. We've also used data poisoning to show that if we tamper with the training data of our ML model, there'll be a drop in the accuracy. Now I'll move on to the data set. So we've used a combination of three data sets here, two Kaggle and one IEEE data set. So the data sets that we've used are the Kaggle's COVID-19 radiography database, IEEE COVID chest X-ray dataset, and Kaggle's COVID-19 X-rays dataset. So on these images, data augmentation was performed, and we've inflated the dataset to about to have a total of 29,498 images in the dataset. And as you can see, these are just few examples. Sir?
Hello. You can carry on. You can carry on. I think somebody has got the mic switched on.
Okay.
If you're not presenting, please switch off your mics. Please mute if you're not presenting. Thank you. Please carry on.
Okay, so these are just few examples that we've shown from our data set, the normal COVID and pneumonia images. So moving on to the methodology of what we've done in our research. So the first step was to create a custom database. So as shown in the previous slide, we've used a combination of three data sets, and we've augmented and inflated the images to create a custom data set. And this custom data set is was split into training and test data set with a 80:20 ratio. And on this, several Python Torch Vision image transformations like converting into tensors, normalization, resizing, etc. were done to fit into the input specifications of our ResNet-18 model. And once this is done, the data loader is prepared and the ResNet-18 model was created. And using this, we've trained like a training data set. And using this, we've on our test data set, we've predicted three output classes, which is COVID, normal, and viral. So this just talks about the image transformations that we've used. We've used resizing, converting to tensors, and normalizations to make sure our input fits the specification that is 224 cross 224. Now Karthika will take over to explain about our model.
Can you please confirm if I'm audible?
Yeah, you're audible.
Yeah, so now we'll move on to our CNN model. So we've actually used transfer learning from a ResNet-18 architecture in order to carry out a feature extraction task. So a ResNet-18 typically comprises of alternating sequential layers, which include convolutional layers, batch normalization layers, pooling layers, dense layers, dropout layers, etc. So the image given here is a sample COVID-19 chest X-ray. And as you can see here, there's a concentration of white regions, which indicates the presence of infection. So next slide, please. So as you can see here, the input image is fed into our first layer, which is the convolutional layer. So the convolutional layer basically generates feature maps based on the concentration of white regions in our chest X-ray. After that, there are alternating pooling layers, as you can see, and the role of a pooling layer is to downsample these feature maps and to prevent overfitting of our model. So the pooling layers essentially makes the model more robust and invariant to image transformations that are brought forth by change in lighting conditions or positions. Finally, as you can see here, there's a fully connected dense layer, which will output the final predicted class based on all the features extracted by the layers before it. So a typical REST 18 architecture has a total of 512 in features, and our model has a total of 3 out features, which are our 3 output classes, namely COVID, pneumonia, and normal images. Next slide, please. So moving on to the hyperparameters that we used in fine-tuning our model. So for our loss function, we used multi-class cross-entropy loss, since our model tries to solve a multi-classification problem. And talking about our optimizer, we chose Adam, since Adam is an efficient optimizer, which is useful in handling sparse gradients. So the default learning rate of Adam is 0.01, and the same learning rate was deployed in fine-tuning our model. So our training and testing was done in batches of 6, and a training batch size comprises of 3,917 images, while a testing batch size comprises of 1,000 images per batch. Training was done for a total of a single epoch, having 340 steps per epoch. Next slide, please. So in order to understand the effect that data poisoning has on machine learning models, we employed an adversarial machine learning approach of data manipulation. So here we provide malicious input by manipulating the existing data in the dataset in an attempt to misguide our model. So out of the 7,940 COVID images that are there in our trained data, 3,400 of those COVID images were overlaid with normal chest X-ray images. So this overlaying or manipulation was done with the help of Python imaging library modules. And this resulted in the corrupted or manipulated image as displayed on the screen. So this corrupted data set was then again used to train our REST 18 model, and we kept the hyperparameters the same as I mentioned before. So at the end of our experimentation, we witnessed a significant drop in our accuracy from a 9% drop from our previous high of 96.48% to a new low of 87.11%. So at the end of our experimentation, we concluded that data poisoning poses a significant threat to machine learning models, and it is important that we have concrete defense mechanisms to safeguard our model from potential threats. Now over to Khushi. She'll be talking about our performance metrics.
I hope I'm audible.
Oh, yes.
Yes.
So far we have talked about the REST 18 model. So along with the REST 18, we have also used 2 other prominent pre-trained model, namely VGG16 and AlexNet, which are used to train a data set. And these were done based on repeated experimentation to decide which architecture is more suitable to train the data set. And at the end of the training, the REST 18 proved to give better accuracy results than VGG16. Next slide. So this table depicts the classification reports of the 3 models, REST 18, AlexNet, and VG16. And it can be understood that the RSNet 18 model performs better than the other 2 pre-trained networks, since it delivers a higher validation accuracy of 96.7%, which is higher than the other 2 models, and a validation loss of 12%, which is lowest among the 3. And the overall test accuracy is about 96.4%, which is higher than the rest of the 2 models. Next slide, please. So this image depicts the confusion matrix of ResNet 18, where over 450 images from each of the classes were correctly classified, while the misclassification are less than 30 images per classes. Next slide. So this curve is the model accuracy curve, which was plotted on the validation data. That is steps per epoch versus the validation accuracy. The curve here increases exponentially over time to reach a maximum validation accuracy of 96.7%, which is desirable during the training. Next slide. So this curve is the model loss accuracy curve, and it's plotted against the steps per epoch versus the validation loss. And this is also done on the validation data set. The curve here decreases exponentially over time to reach to about 12%. Next slide.
Why it is taking time in changing slides?
I'm sorry.
Why it is taking time in changing the slides?
Sir, I am changing as soon as she. I think there is some
Okay.
network problem. Sorry.
Um, and this shows the comparison after the data poisoning, and it can be seen that after the data poisoning, the validation accuracy has been dropped to drop significantly to about 9% to 88%. And yeah, thank you.
Thank you so
This is
much.
the end.
Can I stop sharing, sir?
You can do it from your own end who is presenting. Okay, questions please. Any question from anybody? Yes, what is the contribution in your work? Can you summarize in 2-3 lines? Can you hear?
Pardon, sir?
Yeah, can you summarize the major contribution of your work?
Yes, sir. So currently we are facing a huge health crisis owing to the pandemic. The whole world is like facing the crisis of the COVID-19. So at present, it is hard for doctors to distinguish a COVID chest X-ray from a chest X-ray. So our work basically helps in making this distinguishing a lot more easier because it does a clear classification of chest X-rays into three classes: normal, viral, pneumonia, and COVID. So this would be a major contributor to the healthcare industry because it would help them perform easy and fast diagnosis.
Good. So you think that you can implement it into the medical professionals, right? It will be valuable
Yes.
suggestions to the medical professionals. Have you
Yes.
tried to implement it in any hospital
Yes,
or anywhere?
No, so we're still in the initial
No, sir.
stages of our model, but if we have a very promising accuracy rate as well, so maybe hopefully in the future we will.
Okay. Okay. Thank you so much for your presentation. Who is the next presenter? Is the
Thank you.
Samuel is ready? Is
Yes, Prof.
Samuel?
Prof, I'm ready. It's just that I'm having challenges uploading my slide.
So
My P-
are you still facing problem in uploading the slides?
Yes, I spoke with Jay and he's assisting with that. I don't know if he's ready with that.
Joe.
Yeah, I haven't received it yet. So we can go to the next presentation in meantime. As soon as I've received it, I will assist him. Yeah.
Sam, why you have not sent it? How much time it will take?
He
Oh,
has
I've sent it
just
to
sent
him.
it now. Yeah.
Okay. So next is Samya Ramesh, right? Samya
Yes, sir.
Yes. So can you go ahead, please?
Sure, sir. Let me just share my screen. Can you see the slide, sir?
Yes, we can see the slides. Yes, go ahead.
Okay. Hi, everyone. I hope everyone's having a good day. I'm Samya Ramesh, and I also have Subiksha Selvarayan here with me to present this paper. We are undergraduates majoring in computer science at SSN College of Engineering, India. And the title of our work is An Adaptive Multi-Layered Approach for DOS Detection and Mitigation. This is the outline of our presentation, so let me just get started with the introduction. A denial of service attack is an attack that targets the availability of the system. So it can basically shut down a system and make it unavailable to its legitimate users. And just in the time frame from like January of last year to March of this year, the number of DDoS attacks have increased by a 55% margin. And not just that, it's it has also become more complex, involving multiple attack vectors. And like one of the most common types of DOS attacks that we see is the volumetric attack or the flood attack. So it basically tries to saturate the bandwidth of the target site. We have used a specific type of flood attack called the UDP flood for our attack simulation. So one of the methods of detecting and preventing a DOS attack is by using an intrusion detection and prevention system. So using that, we can monitor the network activity and take necessary preventive actions. For instance, dropping the malicious packets and blocking the offending IP addresses. So, an intrusion detection system can essentially have different detection strategies. The least complex one being the signature based IDS that monitors the inbound network traffic and tries to find any pattern or sequence that matches with past attack signatures. So, our approach is also a signature based approach that relies on predefined patterns to detect the attack. And then there's the anomaly based approach that uses machine learning models or statistical techniques to predict if an attack is ongoing. And we also have the policy based approach that that usually involves configuring security policies to detect the intrusion. And the combination of two or more of these approaches would give us the hybrid detection model. But for our proposed model, we are sticking with the signature based approach. So even with such varied detection strategies, an IDS system still has its own set of limitations. When we talk about the signature-based model, it relies heavily on the predefined rules that we provided. So it can't detect any new attacks. And when it comes to the anomaly-based detection model, it's usually associated with having a high false positive rate, and it tends to be computationally complex and it incurs some overhead. And when we talk about an IDS system, it's usually located on the network boundary. So it has very limited visibility of what actually happens inside the network. So that could be a potential disadvantage in some use case scenarios. And then there's also the limitation of packet fragmentation. So, an attacker who is smart enough can craft fragments in such a way that it does not match the signature that we've specified in our signature based IDs and easily bypass the firewall. So, we hope to tackle some of the limitations associated with signature based model in our proposed system. This is the experimental setup that we've used for running our simulations. The network emulator that we used is called MiniNet. So it allowed us to rapidly prototype different network configurations and run the attack simulations under different network topologies. This is the specific topology that we used for running our simulations. So as you can see, there are three hosts and we have a switch that routes packets through these hosts, and each of these hosts have like a specific function associated with them. So host h1 is the attacker, h2 is the victim node or the target that we'll be attacking, and h3 is the node where our idps system is actually located. So all of the messages that actually go to the target are actually passed through the idps, which is node h3. So it sort of acts like a packet filter and drops the malicious packets at this point. This is a high-level overview of our proposed architecture. So we have actually taken into consideration a lot of factors before disallowing access to a particular IP. So it basically has three detection levels, as you can see here. The first level makes use of packet frequency for detection, since we believe that it's one of the fundamental parameter that we talk about with respect to volumetric attacks in general. So once that stage is done, we move on to the second level where we check if an incoming packet source IP is actually trusted and if it's part of the whitelisted IP database that we have locally. And even after these two levels, our system is still susceptible to IP spoofing, where the attacker can spoof the IP address and give one of the addresses that's actually presented in our trusted DB. So what we have proposed is a third level called the Deep Packet Inspection Unit, which actually looks at other parameters in the packet header, for instance, like the source port, destination port, and the size of the payload to predict if an actual packet is a part of a DOS attack or if it's just a benign packet. And we also have a logging module to log all of the incidents. So once it's been validated by these three levels in our IDPS system, the packet actually gets sent to the packet forwarding module, which forwards it to the intended destination. Next, I call upon Subiksha to carry on with the multi-layered approach.
Thank you, Samya. Can you hear me?
Yeah, I can hear you.
Okay, so here we have the flowchart that depicts the multi-layered approach that we have adopted. Here the incoming packets are simulated by Scapy and they're sent to the packet sniffer and threshold modifier. The threshold modifier is a component that calculates the incoming packet frequency threshold at predefined intervals of time and updates the value for the allowed frequency threshold in the IDPS configuration. And the packets coming to the IDPS, the IDPS checks the current packet frequency with the threshold. And if the packet frequency is lesser than the threshold, then the packets are forwarded to the destination. And if they're greater than the threshold, then they're sent to the first level for further inspection. Next slide. Here we have the result that we obtained after conducting the experiment. Here, this is the terminal for IDPS system, and the IDPS forwards the packet from source to destination after looking at the frequency, and it will forward the packets only if the frequency is lesser than the threshold frequency. And if the frequency is greater, the packets are flagged as malicious and sent for further inspection. After further inspection, if the packets are considered malicious, the packets are dropped. In addition to drop of the packets, we have also implemented blocking of attacker's IP. So as we can see here, once the attacker's IP is blocked, when the attacker tries to send a packet from source to destination, it says destination host unreachable, which basically means the attacker won't be able to send any more packets to the victim. Here we have the graph which shows the variation of DOS time with respect to DOS interval. So here the DOS interval is taken for 6 iterations, and the DOS time is basically the time which requires the time for the CPU utilization to reach 100%. So as we can see here, for the DOS interval 0.001, there is a slump in DOS time, and for further decrease in the interval, the DOS time gives erratic results. So we just go for 0.0001 as the optimal interval for the UDP flood attack that we are simulating here. And here we have the average CPU utilization of different levels of network traffic for varying DOS intervals. So it can be seen that the average CPU utilization for normal traffic is just above 0%. And for DOS, you can see it increase to maximum utilization for the interval 0.0001, which optimum interval that we have adopted here. And it can also be seen that for normal traffic, it increases furthermore. And once we drop the packets and attacker's IP is blocked, we see that the CPU utilization reduces to less than 60% normal IDPS system. Here we have the performance metrics of the proposed approach compared against generic IDPS types. We have accuracy, false positive, negative rate, resource utilization, and detection rate for new attacks. As it can be seen here, the detection rate for new attacks for our proposed system is moderate. This is because the frequency that we set as threshold is not it can change dynamically, but then we have set the frequency here. The future work that can be done to our paper is, as our system follows signature-based detection, we can also combine that with anomaly-based detection to get more accurate results. And we can also use an ML model that uses online learning to train in real time, which basically gets the dynamic data, and that will also produce more accurate results. And here we have just taken the frequency from the packet header to flag the packets. but we can also look into other parameters to that might help the DOS.
Thank you for your attention. We are open to take questions now.
Any question, please? Questions from the audience?
Yes, Prof. Just one question. Has this been used in any real-time application as such, or is it just in a lab experiment at this stage?
At this stage, it's just a lab experiment that we've run simulations inside a network emulator. We've not tested it in a real-time application as of now.
Okay, that's good. Thank you very much.
Thank you for the question.
So have you improved the algorithm? Any algorithm, or what is the major contribution till time? I saw that you was explaining how the ideas they works, but what is your major contributions?
Yes, sir. So what we actually aim to do with this work is to actually reduce the computational complexity of the algorithm, because all of the IDPS systems that are being used today use some sort of ML algorithm which is computationally complex and it incurs a lot of overhead. So we wanted to build an IDPS system that's solely based on signature based model and improve the detection rates for such a model, and that would also use like very little CPU utilization. So here our IDPS system, only during the DOS attack it's reaching 100% utilization, and the other times it's like less than 60%, around 55 percentage utilization. So that's what we've tried to achieve, and we've done that.
Okay, so it is your master works or your PhD works or the bachelor's?
Actually, we are undergraduates, sir, so we're still doing bachelor's.
Okay, so you are in a final year students, right?
Yes, sir.
So you graduated or you are going to graduate?
We're graduating next year, sir.
Okay, it is you started your project recently, right?
Yes, sir.
It's okay. Congratulations. Good work. Keep it up.
Thank you, sir.
Thank you, sir.
Yeah, I think this is very good work. Just to quote an incident that happened down in South Africa not so long ago, our major Transnet network was attacked and a DOS attacked, and it was down for a whole week.
No, at undergraduate level it is very good, but most of them they are leaving after the undergraduate, so it is not going to implement it in a real-time scenario. That is the basic issue. We are facing. Means as a professors, what we are facing, that they are doing the simulation and after then they get a job and they will leave. It's okay, but at the undergraduate level it is a good. So I think you are able to upload the slides.
Yes, thank you. Yeah, I can share the slide.
Yes, where is the moderator? I can't see him. Moderator is there.
Oh, yes, he's here.
Which name?
Giulio Biondi, if I may pronounce it correctly.
Giulio Biondi means the guy has changed now.
I'm here, Professor.
Yes, he's changed now.
Why? He has not mentioned anything to us. Okay, he's a moderator now. I was searching my guy. What is his name? Since
Andrea,
yes.
Screen.
Okay, so this Biondi has, I think he informed to the Osvaldo that session is not started and session chair is not there.
I am here, Professor Misra.
No, I think, okay, it's okay. I think the last session is started in time, right, Jay?
Yeah.
Yes.
On time.
Which one? Sorry, which one?
The last one.
Yeah.
At 2. It is started in time.
Yeah, we started perfectly on time.
No, but I received a message from Osvaldo that I'm not there, but I say that it's okay.
Okay.
Well,
Perfect.
Sorry, I'm battling to share my screen now.
are you able to share?
Can you see the screen? No.
No. Is the file is corrupted?
No. The file is opening. File is opening. If I click on share, it doesn't share. Okay, let me disconnect and connect again quickly. Just give me a second. Okay, can you see my screen now?
Yes, yes, yes.
All right, okay, thank you. Samuel, can you hear me?
Samuel.
Yes,
Please
yes.
go
Thank
ahead.
you so much.
Please go ahead.
All right. Hi, everyone. Thanks for your patience. Yes, so this, if you could go back, that's the title of my presentation. It's more of a comprehensive review, which is going to discuss the nature-inspired search techniques which have been used in estimating optimal configuration size, cost, and reliability of a mini-grid hybrid renewable energy system. All right. My name is Samuel Ofori Frimpong, and I have some co-authors named there. This is going to be the outline of my presentation. There will be a brief introduction which will look at the background of hybrid renewable energy system. I would also discuss an overview of the mini-grid hybrid renewable energy system, and then zoom into the optimization techniques that have been used. My focus is to bring an updated literature on nature-inspired methods that have been utilized for optimizing hybrid renewable energy system. Then having given that, there is some advancement that is going on there I would want to share. Then I will conclude by giving some future direction of this work. I've also attached some references that could be used for any further studies. So to start with, energy is paramount in our economic development or socioeconomic development or improving quality of life. And the need to find a sustainable energy system is equally important. Renewable energy system offers more advantages when it comes to its usage. If, for example, we know of its environmentally friendliness, it's also able to provide us systems of power generation system which can be implemented in either isolated or grid mode, unlike the grid system which needs so much cost to be extended to rural areas or where power is not. Renewable energy can apparently just be implemented for special or for the locality. It is also a bit economical when it is properly sized. And for that reason, there is a need for a thorough studies or preliminary analysis or assessment before implementing it. Despite all these benefits, there are some challenges when deploying a renewable hybrid system for a distant community. Some of these challenges would actually amount to the dependence of these resources on climatic weather conditions. For example, the solar energy is highly dependent or solely dependent on the sun, when actually is also so much dependent on the availability of wind speed or the wind blowing. All right. So these challenges can actually be addressed. Please, if you could go to the next slide. When we hybridize this system by either combining two or more of these renewable systems. However, just fusing them also have some constraints if they are not properly sized. If we just have to just combine them in any quantity, then it also breaks the boundary of the economics or the cost involved. So there is a need for feasibility analysis at the inception of the system in order to curtail excessive cost and then to properly size the system to supply reliable power. In as much as we sizing, there are so many other constraints that must be taken into consideration, that is to meet the load demand. Hence, optimal configuration of hybrid renewable energy system would always include at least maximizing the output or the power that could be generated from the system. But at least we should also have in mind that we don't want to exceed or have excess cost. Then optimization problem of such system normally comes out not to be a linear. It comes in a non-linear fashion. And for that, the well-known or the traditional optimization methods, that is a classical method, have some challenges when resolving or solving these kind of problems. It has been noticed from the literature review that the approximation method, that is what we normally call the meta heuristic, are performing so well when it comes to optimizing hybrid renewable energy system. There are so many reasons that this might be the case, looking at the self-adaptive nature of meta-heuristics, and then their ability to move or find escape local minima. Right, so meta-heuristic algorithms have wide application in hybrid renewable energy system. A brief overview of mini-grid is to actually just establish the grounds for why I chose mini-grid, and then considering the advantages of meta-heuristic, its use in mini-grid hybrid renewable energy system. First, mini-grid is a locally based electricity provider or a system that is used to distribute energy, which is less costly, and then it's more of an environmental benefit. The mini-grid basically has a feature that establishes the fact that it doesn't cost so much. It could be implemented in any local setting, not really connected to the grid. Then configuration of the grid-independent mini-grid must account for optimal sizing, which I think I have already made mention of, looking at the cost. Okay, so mini-grid actually always have to consider the cost factor, and these economics actually would also sometimes compromise reliability. So a problem is presented where, in most cases, it becomes an optimization problem. So to optimize a hybrid renewable system, these are the requirement, what need mostly to be considered. The data requirement, that means the kind of data that would be optimized. For example, if we're considering the solar energy, wind energy, biomass, and so on and so forth, the data regarding their production or the availability of these data need a thorough studies before we actually could size or think of what could the technology to implement. Again, there is a need for the energy system models, the mathematical formulation of these technologies or renewable technologies that would actually generate the power. We have to find a way of expressing that system in a mathematical formulation in order to do the estimation. Now, with any optimization problem, there is a need to find an objective function. In most cases, it could be the cost of the hybrid system by combining or purchasing different renewable technologies, trying to fuse them to generate reliable power. We sum up all these costs and then say that we expect a cost at this particular level. However, there should be certain reliability. So reliability, technical factors could be an objective function, but in most cases, the sizing of this system is what is considered as the objective function. There are several techniques that have been deployed when it comes to optimizing hybrid renewable energy system. This optimization, apparently as I've discussed in the previous slide, is a way of finding either an optimum or a minimum of a particular function in mathematics. So a mathematical expression that could actually be evaluated to give a minimum or a maximum number. Common among these approaches have been the classical or analytical techniques, which includes linear programming, mixed integer linear programming, trade-off, graphical, and so on and so forth. These techniques do have their limitations. If, for example, when you choose the graph approach or graphical approach wouldn't be fit for more than 3, perhaps even 2 constraints or variables if you're considering more. So the graph has its limitation. For linear programming, as the name suggests, if the problem is non-linear, there is a huge issue there. So it cannot solve a continuous optimization. So a better way of dealing with the hybrid renewable energy system optimization is to use these artificial intelligence and computational intelligence techniques, which are mainly called the evolutionary computations. Purely, this swarm intelligence is an example, artificial immune system, fuzzy logic, and so on and so forth. These are able to self-adapt, and for that, they are able to escape any local minimum and then find an optimal solution. Their use in hybrid renewable energy optimization has been tremendous, and they've proved to have
Hello. Hello, Jay.
Hello. I think we lost Samuel.
I think disconnected, right?
I think so. Yes, I think he lost connection, perhaps.
Yes, because suddenly he stopped speaking.
Yes.
It's okay. He is about to end. So I think that this is the last presentation for today, for this session, right?
Yes. Yeah, he had 2 more slides. Actually, 1 more slide, and then conclusion, future work. If I may show.
Yes, you may go to the conclusion. Yes. If anybody has any questions, you can send me in the end.
Can you see the screen?
Yes.
Okay. All right. Let me hold on to that. Well, I think there is 1 presentation remaining in the next session. There's only 1 presentation there, right?
In this session?
No, in the next one.
Yes, in next one, there is 1 presentation, yes. I couldn't understand. What do you mean? Yes, only one
Yeah.
presentation is there. Only one, yes.
Yes. There was only one day.
Emmanuel, is he present?
I'm sure.
Emmanuel. I can't see the Emmanuel, right?
No, I can't see Emmanuel either. This is his time. Don't think so. He's here, Prof.
Yes.
Yeah.
Good afternoon. Good afternoon. Yes, Jaya. So I think we can give a break.
Sure. What time do we meet in the next session?
I think after 7:45. This means after 15 minutes, right?
Yes. After, yeah.
You can discuss with me, I think, with WhatsApp. Have you filled all those for who was present and who was not present?
Yes.
You have filled?
Yes. I didn't submit it. I've got it on a spreadsheet, which I can share with you. Can I email it to you?
Okay, you can share with me, or maybe we can discuss on WhatsApp. It is not a good platform to talk with you, right?
Sure. Okay. All right. Okay.
So what is your WhatsApp? You know my WhatsApp number?
I'll send it off to you. I'll send it off to you an email. Mine. Okay. Thank you very much. We'll meet all of you in the next session at 17:45. Is that right?
Okay, thank you. I will set up the countdown.
Thank you.
No, do not count down. Do not count down.
Oh, I mean the break screen.
Yeah, just to leave it, okay, for 15 minutes.
Yeah, it's 15 minutes.
Yeah, so the guys may not go. Idris.
Yes, Prof.
Yes, how are you?
I'm doing all right, Prof.
Okay, so you presented well because I was not there. That's why my point was yesterday your presentation was right.
I had some issues with my audio on my computer, so I used my phone to do the presentation.
When was your
finished?
No, you was not present in the morning. You was not present yesterday evening. So when you presented, that's why my point is.
No, I presented 8:45 Nigerian time, so it's 9:45. I presented my paper, data selection.
Okay, so but he was not there in the beginning. He was not there in the beginning. I started, and after then I had a keynote and I left there. But he was not there because you have two papers, right?
Yeah, we have two papers.
Okay.
So our colleagues to present the paper, they had some challenges yesterday. So I contacted them. They said they wanted to present today, but then one had an emergency. He has to travel to Kogi State. So and he was on his way. I couldn't reach him. So that's why I just presented the one that is scheduled today.
But so who paid for the both papers?
I did pay for the both papers. I registered them. I paid, yeah.
How you paid it?
I paid online using a transfer. I delegated someone to pay for me because you know the challenges we have with exchange rate. So I have a person in Portugal, so he have the currency in
euro.
So I asked him
please, Idris, please send that receipt to me, right? Because we have to all those to as a record, because last time we have several issues with the Nigerian authors, right? I mean, it is not
All
a
right.
miss, but please send it, but just for the record.
All right. So the receipt is, I think, it's in Portuguese. I couldn't even read it.
No, it
but
is
then-
very clear. Don't worry. If it is there,
Yeah.
just to
Yeah, it is.
send. Okay. There is
Yeah,
a
immediately after this call, I will send it to you. Yeah.
and also please try to be present in time. Emergency and all those things, they are very common in this part
Yeah.
of the world, right? So these
Yeah.
are thousands of the excuses. This is my 12th year in this country, right? So
Yeah.
you understand. And yesterday it was
Yeah.
highly disappointing because majority of the Nigerian authors, except today one, it is from the Gloria, from the Kennedy. He is I think treasurer in the IEEE Nigeria section. Except none of the authors were present in time. Even in the morning, he was not present in time in the session. We have closed the session in beginning.
All right. I think I presented in time.
No, I don't know, but he was not present in the beginning of the session. Jai, means I was there. I started the session. After then,
I was not. I think I joined 8:20, 20 minutes past 8. Yeah. 20 minutes past 9. Yeah, the CEST time.
It's okay. It's okay because I didn't get anybody. It's okay. But well, have you submitted any paper to ICCSA?
No, I did not. I don't have any work currently.
So you got the call for papers, right?
Yes, I saw your email.
Okay. Where are you affiliated with? Which university, Idris?
I am teaching at Ahmad Bello University, Zaria.
Okay, ABU Zaria, right?
Yes, Department of Computer Science.
Okay. As a lecturer?
Yes. But I'm currently doing my PhD with Bayero University, Kano. So I'm concluding the program.
Okay, with the Bayero University. Who is your supervisor in Bayero?
Associate Professor Bashir Shehu Galarenchi.
Okay. So anything else from the authors? Any questions? We can talk. This is the time we can discuss. We can share our experience. We can share something what you want to discuss. It's okay. So this is the tea time. Thank you, Idris. But just to please, in all the international events, because there are something important, majority of the Nigerians, they skip something during the revision, because they do not consider. We also pay the 10 best paper award, and it is a cash prize of 500 euro. It is a cash prize.
Okay.
And it depends on all the things starting from beginning of the submission process. Means if your paper is in proper format or not, then what are the comments of the reviewers, and how you are going to respond to the reviewers' comments. It is reflecting or not. After then you are presenting. How are you presenting your presentation? Everything is counted. And we select 10 authors from the whole conference. And certainly from 2, 3, 4 from our these 3 conferences, SEPA and ISQ and TDSDP. 3, we started since yesterday and we are going to end tomorrow evening. So it is the biggest event in ICCSA. So we all minimum 3 or maybe we can have the 4 best paper awards. And sometimes, despite of the paper is very good, their presentation, their organization of the works, their responsiveness to the reviewers' comments force me to down to the means they missed it. For example, last year, one paper was really very good, but they missed to get it. It's okay, no problem. But that's why I'm means.
Okay. Alaikum salam. Network yana bin matsala. Network ɗina.
Jay, can we talk?
Yes. I've just sent an email to you with my number as well.
Yeah, or not my phone number. You can add it 234.
Okay. 234.
Have you noted? I told you or not? Jay.
Just give me a second. 1 second. Okay, sorry, you can go ahead. Yes. 234. Prof, please go ahead.
Yes.
234.
234 7030
Yes.
851086.
Okay, great. Thanks.
Nessuna idea? L'impianto è completamente a carico. Cioè l'impianto sì.
Sorry. Yes, dear. Yeah. Is anybody the last session in the SEPA? Emmanuel is there. Is Emmanuel there? Is Emmanuel there?
No, Prof, I don't think so. But there is one person who's a fellow JITSA.
Yeah.
Would you be able to please change the name so we can see who you are?
If it's not him, then there is no one from the last session.
There's only one paper is there. Okay, so this is the last.
Yeah.
Any remaining paper presenters who has not presented in SEPA, this is the last chance. Is anybody? So in absence of the author, it is already 4 minutes off. I thank you to each one of you who has shown interest in the SEPA in software engineering, and today is the, you see that we started yesterday morning and it is going to be end today. We collected around 100 papers, and after then we have the 40 papers in SEPA. Tomorrow we are starting with the ISSQ. That conference is more on software quality, and after then tools and techniques in software development process at the end in the afternoon session. So if thank you so much for your interest. Why I'm disconnected?
No,
hello,
can you hear
me?
Yes, we can hear you.
If it is showing I'm disconnected. So again we say thank you, a big thank you, and please be present in the this ending ceremony. I think you will get an email from ICCSA. Also, there are opportunities for all the authors of the SEPA, especially the presentation issues from the developing countries are not very good. This is not, I'm not very comfortable. See, the last presentation is also from one of my sister university in the landmark university, but the author is not present. It is not very good things, but I observed that African and Indians who are majority of them, they were not came in time, except few cases. So no issue. It's okay. Your papers is published, but in IEEE it is mandatory to present, and also that is a post-conference proceeding. Finally, I send a email to all the authors that you have opportunity to submit ICIIA. In fact, the deadline is closed, but I can still consider if you have any good works. It is also a Springer CCIS. And we will also select some of the papers from the conference for the special issue, and you will be notified if your paper will be selected. There is a committee who is going to select the papers. Again, this is based on the presentation, based on the quality of the works, and so on. So thank you so much. And in absence of you have any questions, please ask. And I request you to join tomorrow morning in the ICCSA session. This is the same with the room B. If you go to the room B, so tomorrow at 9 we will meet. There are very wonderful presentations tomorrow morning. Right? Any other question? Any other question?
I think everything is fine.
So, Wendy. I think we can close the session, right?
I think so, Professor. So I will stop the YouTube streaming now.
Yes, yes, please.
Okay, so the YouTube stream is over. And